So it is a pleasure to speak this afternoon also about this A-25 project. That was a very successful project. This is a project that opened to traffic back in May of 2011. It's almost a year already. And it opened actually to traffic 2 months ahead of time. And it was a great collaborative process with everyone involved on the project, from the owner, the design builder, and all of us. We really have great memories to this day of having gone into the trenches together on this project. Of course, we don't want to forget the members of the team. Macquarie is the concessionaire, and concession A-25 is the entity that manages the concession for 35 years, and the design builder joint venture is Kiewit Parsons as a joint venture. And of course, this project, part of the success is also we've been able to marry successfully the expertise and experience of national design builders with local firms, the knowledge and expertise of local firms such as Geneva, Qualitas, and others. And IBT also worked on this project with us. They did the independent check of the cable stay bridge. And of course, we have the operations, Miller, and also Twenscore is the operations also for the tolling system on this project. Most people are not aware that the city of Montreal is actually an island. And north of it is another island, the city of Laval. And between the cities of Montreal and Laval, we have the Highway 25 that goes from the southern part of Montreal into Laval, but there is a missing link that is the 7.2 kilometers right before you cross over from Montreal to Laval towards the eastern end of both islands. And the project really consisted of building the remaining 7.2 kilometers of highway with the 1.2 kilometer of a new 6-lane bridge over the river. It also included, of course, overpasses and other interchanges, 4 other interchanges, including the system one with A440, which is another major east-west highway in Laval. Oh my gosh, the level of pride that this whole project did for this community. I mean, at the beginning, people were skeptical because of the P3, because of also of the design build processes. But as we started working with the community, because we did during the entire time during the entire 4 years that we were designing and building this project, and you could feel the excitement building up. And when we opened, just before we opened to traffic, we had a community event on the bridge. We opened it to everyone so they can come and walk. And it was raining that day. It was a very cold, rainy day. And we had over 5,000 people that Saturday who came on. And it just excitement. It was amazing. And on both sides of the bridge in Montreal, there were apartment buildings and homes, residential. It was a residential neighborhood. And people would just sit, and there was a senior citizen complex. They would actually put their chairs outside to sit and watch the construction. So I'm sure life has changed a lot since this bridge opened to traffic. Not as much excitement in the neighborhood. So the objective very early on was, what would it take to deliver this project in 4 years? We know what the designs are, what the design process is, what the different phases, the construction phases, and all of that. But what we really wanted to do is to identify what's on the critical path. What does need to occur in order for us to be able to deliver this project on time. And so we've developed schedules of construction, design, but really we integrated the schedule. And one of the major, what I mentioned earlier, major challenge on this project was the environmental permitting that was ours to do. And this project, when it was approved by the government of Quebec, came with an environmental decree that had 33 conditions that we had to meet in order to successfully deliver this, to receive permits to actually deliver this project. And so we also had to look at the critical elements and how we're going to obtain those permits to be able to start them earlier than the rest of the construction, how we were going to manage all of this. So previous phase, so we looked at what are our risks and how do we manage our risk during this whole process. So risk identification, of course, and management, this is an overall part of what we do in the design build environment. For P3, it's even more critical that we do that because of the severe liability and all the key players like the lenders, engineers, and all the terms, the financial terms that we have to live by. And we had to meet in the project schedule that was critical for us to have those permits on time. And some of the critical items is also we were responsible for public consultation because the MTQ, the Ministry of Transportation of Quebec, the MTQ decided that we needed to incorporate public's opinion and ideas about the aesthetics of the project into the project. And the environmental agencies also decided that this had to be done before we even applied for a permit on the project. And we had to document and show how we incorporated the public's opinion and ideas and feedback into the project. We never stopped talking. We never stopped talking, and no matter how bad it seemed, we always thought about we have to resolve this. We have no choice but to be successful. And so we went back, we spoke with people, we negotiated, and also when I went into those meetings with these agencies, I knew what I could negotiate, what concession I could make, let's put it this way. And I worked very closely with the design team at the time, the construction team, and we knew what we could offer to those communities while we said no to some of the things that we knew we couldn't do. And we've always been very honest and plain with them. We never tried to play games in terms of design. We were always very clear about what we could or could not do and how we were always willing to work with them. And so we had to do all of that. And now we had to speak with the provincial, the Ministry of Environmental I'm sorry, but I don't remember, MEDP, Development, that's in French, so Ministry of Environment, okay? And we had to work with them, but they had a very cumbersome process over in Quebec. When you apply for a permit to construct, there is the City of Montreal that has to actually, you have to deposit your permit application with the City of Montreal. And within the City of Montreal, there are communities, jurisdictions that they have to also review your applications and determine whether or not you're in compliance with all their local regulations. And then the City of Montreal does the same thing. And after that, then you go to the provincial and says, I have all the authorization and all my letters from the other municipalities, so could you please, give us the permit? And anytime they reject a permit application, the process starts all over again. And you can imagine there was not a lot of time to really engage in all this consensus building as we were applying for the process. The day after the signing of the agreement, we started talking to the environmental agencies. We went up to Quebec City and met with the Ministry of Environment. And what we had to do practically is to explain, this is what a design build is, how they've never done it. This is what a design build really entails. This is the effort. And this is the schedule we have, and we do have to meet our obligations. So we're looking forward to you helping us to do that, but we would like to hear from you because we would like to help you help us. And I must say, they were very willing to listen to us. And that was a major plus, because without their collaboration, there is no way we would have been able to do this project, to deliver on time.
Main river crossing of the River de Prairie. Regine had mentioned that it's a 7.2 kilometer project, but arguably the most dramatic part of the facets of the project were crossing the river at only a 1.2 kilometer segment. So for these slides, I'm going to break it down into sort of two components. One is the approach spans, which is more than 2,000 feet of approach, steel girders in this case, along the shallower portion of the river, and then a 280 meter cable stay bridge crossing across the deeper part of the river over on the Laval side of the bridge. For the A-25 project, the crossing the River de Prairie in the summertime, it seems very easy because it's sort of a lazy river, if you will. But in the wintertime, there's severe icing conditions. We had to deal with ice that was almost a meter thick
And it wasn't just for the design of the permanent structure, the bridge, for the ice flows that would come down in the springtime. But we had to deal with those ice flows and the challenges of the ice impacts onto our temporary structures, the cofferdams. We had the causeway, and we had batter piles that would lift the ice sheets up and break them off so they wouldn't crash into the causeway and destroy it. The causeway survived 3 winters. That was quite good for a temporary structure. So we really were challenged by the ice more so than anything else. In the summertime, it was a pleasure. There were some environmental concerns. We couldn't work in the river during the summer because of the environmental impacts with the fish and the sturgeon breeding ground. But we had a lot of good workarounds. But the winter environment was by far the most challenging. We did work off the ice in the wintertime some. We used the ice as a template, actually. We drilled holes in the ice to use it as a driving template for some of the piles. So that was a bit of innovation the construction guys came up with, and it worked out really well.
It is in fact dammed up just a short ways upstream by Hydro-Quebec. They have a dam upstream for power generation. So at first glance you would think this is pretty straightforward now. We've gotten ourselves out of the box. But you find out it's actually a somewhat treacherous river. And that's when it comes into wintertime, because we had ice thicknesses that we needed to design for of up to 1 meter in thickness. So this was a picture of the river prior to any of the construction activities. So the guys did persevere. We were able to work through several of the winters. There was some minor winter shutdown periods, but there was concrete pouring on the eve of Christmas Eve. And they did persevere through much of the construction activities. And you can see now this is facing now towards Montreal, and all the in-water work was actually through the ice, so the solid form of water, if you will.
Well, you know, all these projects, and you're right, I worked on the Carquinez, the Tacoma Narrows leading up to this, but on A-25 it really comes down to meeting and beating the schedule and some of the restrictions that are imposed. Particularly, I remember the Rock Island at Tower Pier 11. We needed to get that Rock Island in, and we didn't get the permits in order to work on that until just a few weeks before that needed to be in place. Had we missed that Rock Island window to get that in place in that few weeks' time before April 1st fish window, we would have lost the whole season. So our crew back in New York, we were working pretty much around the clock, days, nights, weekends, to get out there and get that design issued so the construction teams could get it built and constructed and be outside of the fish window. And it was good because I was up there just before it happened, and you could see all the equipment was in place. They were just waiting for that green light and that issue for construction plans. It was exciting.
But as it turns out, ice in the winter really wasn't the biggest problem. It was ice in the spring, because the ice, when it melts, it breaks up into acre-sized sheets that flow downstream and need to find a place to go. So to combat that, you can see on the trestle, there's a whole series of steel raker piles, and they turned out to be pretty effective. That trestle survived 3 winters, and what those raker piles do, actually, they lift up the front edge of the ice and they break it off. And they break it off by bending so that the piles of the trestle itself do not have to take the brunt of the force from those large ice flows. So that was something that turned out to be very effective in this particular, what would seemingly be a straightforward solution. And here now you see spring has come, work is well underway. The construction of the approach piers in the back, you can sort of see the sequence. We use drilled shafts that continued on up into columns, and then the columns were capped off with pier caps. Back here, they're pretty much in place. That's one of the pier caps being constructed. And here out in the leading edge of the construction sequences are most of the drilled shaft cans are in place. And you see they extend up above the water line a short distance, and those were left in place to armor the drilled shaft piles from ice abrasion during the life of the structure. So all that time, while the site work was going on, the steel was being fabricated in Quebec City. It's about a 3-hour drive to the east from the project site. Here are some of the large plate girders that were being constructed. There was actually, the approach spans were 5 girder lines of plate girders. This is 3 of them being trial assembled. And we use the somewhat unique substringer system, where you see here one of the substringers is being assembled and it sits on the cross frames. So that allowed us to have to minimize the girder lines, which then of course minimized the amount of pieces to be transported and amount of pieces to be erected and lifted. So that turned out to be a good advantage, actually a good decision early in the construction phase, and early in the tender phase, and it worked out well not only in design but in construction. And these girders were all transported to the project site by rail. They were shipped upright by rail and delivered to a siding not very far from the project site, and then brought down to that rock causeway that I had shown you before on truck-mounted trailers. So also early on in tender design, I mentioned there was not a lot of appetite working near the power lines on the upstream side, but we conceived of an idea where we would design, procure, and deliver custom gantry cranes that could lift the segments off of the causeway, because even with the causeway being downstream, it really wasn't very practical for a more than 100-foot wide bridge to be lifting from the causeway all the way over to the far side for girder erection. So we decided that we would pursue this, and the Kiwa guys came up with a good solution to procure the gantries, and in fact that is what we did. You might have picked up on it in some of the earlier slides. But these gantries had the capability of lifting more than 65 tons and easily could erect these are the pier segments. You see now clearly the 5 girder lines. They're all completely erected on that finger of the island. It was kept everything out of the water, as well as the shoring towers were on the finger. So at that time there was really still no in-water work going on. And then to bring the big drop-in segments, these are 96-meter spans. I think I mentioned before, we didn't particularly want to have to lift 2 at a time, which is customary for bracing and stability of the girders. So we implemented a scheme of bracing that top flange with a truss. So that truss actually stabilized a single girder so it could span a full 96 meters without losing its stability during the erection phase. And here's another view of the cantilever. There's a particular innovation here that's not apparent to the eye. It's actually something that in hindsight we possibly could have patented. It has been used since then by others. As far as I know, it was the first time it was ever used, and it was one of those things where the need was the mother of invention. So what happens on a cable stay bridge of this type, we wanted to keep the tower simple and clean and to follow the clean forms and sleekness of the cable stay bridge. So we needed to have the towers, the vertical line of the towers in line with the vertical plane of the stays, and also in line with the horizontal line of that edge girder. It's an I-shaped edge girder. And the usual way to do that, and the way it's been done in the past, is you frame the edge girder directly into the front face of the tower. This is the Green Bridge in Australia. It was designed by IBT, but it's a good example of how this had been done in the past. And we set out to do that, actually, but it didn't work out because the span was a little bit long at 280 meters, and the thermal range in Montreal from winter to summer is a pretty big swing. So in order to accommodate that, it would have overstressed the tower and the foundation. So it really was not a workable solution. So what we needed to do is find a way where we could frame around the tower. And we conceived of this approach where we would, the eye girder, the edge eye girder would come and frame into a steel box girder and sort of sidestep the tower, and then back into a steel box girder, and then continue on its way across the span. So we studied that from an engineering point of view. This is one of the models, and this box girder extends only 2 bays on the cable stay bridge. So you can see the web of the eye girder is in line with the outside web of the box girder, and the sidestep eye girder is in line with the inside web of the box girder. In that way, the load could flow around the tower, and we were able to leave this exclusion zone and provide that, in that case, expansion bearings where we could accommodate the thermal expansion of the edge girders. And it worked out pretty well. This is the view of what it looked like during construction. You can see these are the box girders. They were quite enormous, actually, but it worked its way around the tower, back in, and you can see now here's where that eye girder that we saw in the other photo is going to continue all the way across the span. And this is the first line of stays with stay anchor that's waiting to receive its stay.
Well, you're right. New York is one of the centers of excellence for our bridge group. We have several major bridge and tunnel offices around the country, but this particular project the main bridge was designed in our New York City office. And we had the construction teams in our office, some of them full-time staff. Some of them would come down for task force meetings. The independent engineer came to New York quite regularly. And we were able to communicate video conference, teleconference. We traveled back and forth to Montreal. But there was that synergy that has to happen on a job to really make it a success. And we were able to do that. Montreal's just a short distance away from New York, so it was a lot of fun. We had the collaboration right there in the office working with the construction teams.
Collaboration is key. We wouldn't have done this project. We need to start very early on and start talking and working with others to make this happen. And I will never be able to say it enough. Coordination, collaboration with the independent engineer, the city of Montreal, and all of them. As a matter of fact, we used to joke around the office that once this project is over, we can all go work for the United Nations.